tonight's Conversations with Great Minds. I'm joined by Guy McPherson, Professor Emeritus of Natural Resources, Ecology, and Evolutionary Biology at the University of Arizona. Guy is one of America's most influential experts on global warming and writes about a variety of climate change-related issues for the Arctic News blog and his own website, Nature Bats Last. In the field of climate science, Guy is best known for his assertion that runaway global warming is already on a path to cause the extinction of the human race, an idea he has written about in his book, Going Dark. Guy McPherson joins us now from our New York City studio. Guy, welcome to the program.
Thank you, Tom. I appreciate the opportunity to be with you today.
Thanks for being with us. First of all, just very briefly, if you could give us a little background on who is Guy McPherson and why should we listen to you, your background, credentials, and what brought you to this place.
Sorry, the sound is cutting out pretty badly here. I think you asked me to give a background on the situation as it currently stands with respect to climate change. Okay.
Yeah.
Well, I think I have a slide that I sent you that we can bring up now that shows carbon dioxide levels and how high they are relative to historical records. Carbon dioxide levels today are probably higher than they have been in the last 20 million years. We've had human beings on the planet for about 2 million years. So carbon dioxide levels in the atmosphere alone represent a major threat to the persistence of humans. In fact, looking only at carbon dioxide, John Davies, writing for the Arctic Methane Emergency Group last September, claimed that we're already at a point that we could end most habitat for humans on Earth by 2040. He's taking into account only carbon dioxide in the atmosphere, one of a handful of greenhouse gases we continue to emit. Tim Garrett had an excellent paper in Climatic Change published in November 2009, but actually submitted in 2007. So we've known since 2007 that only collapse of industrial civilization prevents runaway climate change. That goes back a long time now. That's 7 years since we've had that information. And obviously we haven't experienced collapse. By collapse, what Tim Garrett is talking about, what I'm talking about, is no fuel at the filling station, no food at the grocery store, no water coming out of the municipal taps. If we don't cease industrial activity, in other words, all industrial activity, we will trigger runaway greenhouse effect. Only collapse prevents runaway greenhouse. And that's just looking at carbon dioxide in the atmosphere. If we go to another slide, I sent you a slide that shows that Earth is within 1% of being uninhabitable, about 1.5 kilometers closer to the sun, according to a paper published last year in the Astrophysical Journal. And Earth goes out of the habitable zone because we get too close to the sun.
Mm-hmm. The Earth is this little dot up in the upper right-hand corner.
Again, that assumes only one of the many greenhouse gases that we're emitting. So we're so close to the sun, we're so close to the inner edge of the habitable zone for life on Earth that even a minor change in atmospheric composition could push us out of the habitable zone. Well, we haven't made minor changes in the atmospheric chemistry of the Earth. We've made major changes in the atmospheric chemistry of the Earth. We're at approximately 400 parts per million carbon dioxide in the atmosphere compared to the 280 parts per million when industrial activity began in the 1700s. We're at nearly 2,000, maybe 1,800 or so parts per billion of methane in the atmosphere relative to about 700 parts per billion at the beginning of the Industrial Revolution. So just considering those two of a handful of greenhouse gases, we've made major changes in atmospheric composition within a relatively short period of time. And so it appears that we could push Earth out of the habitable zone by making profound changes in atmospheric chemistry.
Okay.
You've probably heard about the contrarian myth that the Earth's temperature has plateaued, global average temperature has plateaued within the last 15, now 16 years, since March of 1998. Well, we now know that heat, and I sent you a slide that shows where that heat is going. If you'll take a look at that slide that shows there's been an acceleration of heat content in the oceans since 1998. So based on land surface temperature records, it appears that global average temperatures have plateaued, but in fact, 13 of the 14 warmest years on record have been since the year 2000, and most of that heat has been being dumped into the oceans, absorbed by the oceans, instead of on land. Well, as we know, ocean is 2/3 or so of the total cover of the Earth. And so that's a lot of potential heat going into the oceans. It could be that when we have an El Nino event, as appears relatively likely later this year, it could be that a bunch of that heat is released from the oceans. Looking at one of the 30 irreversible feedback loops we've triggered, or self-reinforcing feedback loops, that of methane in the atmosphere. If you'll take a look at that slide of the globe that shows methane concentration in the atmosphere, you can see that particularly over the northern hemisphere and especially over the Arctic, we see a tremendous amount of methane being released into the atmosphere.
That was not there 50 years ago.
That's right. That's right. It was not there 50 years ago. It wasn't even there at this sort of scale 10, 20 years ago. So within the last couple of decades, we have apparently triggered the clathrate gun. Firing the clathrate gun is the event that James Hansen was particularly worried about in his book, Storms of My Grandchildren. And if you look at methane levels about a month ago, atmospheric methane levels from about a month ago, there's a lot of dark red up there in the northern portion of the northern hemisphere. And that dark red indicates a lot of methane in the atmosphere. Just that one self-reinforcing feedback loop, methane bubbling out of the Arctic Ocean, which is reported in the scientific literature in Science in March of 2010. That one self-reinforcing feedback loop is equivalent to 1,000 to 10,000 gigatons of carbon, compared to the about 300 gigatons of carbon we burn through burning fossil fuels so far.
Since 1850.
We know, go ahead, I'm sorry.
Since 1850. From 1850 to now, we've burned about 300 billion tons of
that's right,
carbon
about
dioxide.
300 gigatons. About 300 gigatons of carbon through burning fossil fuels. And this is considerably more than that.
Yeah.
This is nearly 40 times, up to nearly 40 times the carbon equivalent found in the methane just in the Arctic alone. And there's methane in the permafrost, and there's methane in the Antarctic as well. So there's methane coming from all kinds of sources. Just that one source, methane coming out of the Arctic Ocean, threatens to release far more carbon equivalent than we burn by burning fossil fuels. According to the authors of a paper in Nature in July 2013, a 50 gigaton burp of methane is, quote, highly possible at any time. So it could be, we have a 50 gigaton burp, that's equivalent to more than 1,000 gigatons of carbon burned by fossil fuels. That's highly possible
Which is
at
almost
any time.
3 times what we've burned since we started the Industrial Revolution, within a matter of weeks or months.
That's right. And as reported in the journal literature in a paper in Global Policy from September 2012, a suite of amplifying feedback mechanisms such as massive methane leaks from the subsea Arctic Ocean have engaged. So it's pretty clear, even in the very conservative scientific literature, that we have triggered a number of self-reinforcing feedback loops. And in particular, this one, runaway methane, could trigger a runaway greenhouse event. And in fact, that's the conclusion of Sam Carana and Malcolm Light, both writing for the Arctic Methane Emergency Group. So if we go to the final slide I sent you, it shows a runaway event, a polynomial or exponential curve fit to the data and extended forward, and whereby we see a global average temperature of more than 4 C by 2030 and more than 10 C above baseline by 2040. We haven't had human beings on a planet at 3.5 C above baseline. So 4 C or 10 C above baseline, those are very large numbers. I want to read to you the conclusion Malcolm Light reached in January of this year, January 2014. He says, quote, the Gulf Stream transport rate started the methane hydrate gun firing in the Arctic in 2007, when its energy per year exceeded 10 million times the amount of energy per year necessary to dissociate subsea Arctic methane hydrates, end quote. So it's pretty clear at this point that we have fired the clathrate gun, and that self-reinforcing feedback loop alone takes us to uninhabitability of this planet for human beings in a relatively short period of time.
So you're talking about something like the Permian mass extinction or the Permian Eocene thermal maximum, a period of time where most species on Earth and in the sea die, including us?
That's right.
And
that's
what
right.
kind of time scale?
Well, we're human animals, and so we need habitat. This isn't... humans won't go extinct because it becomes too warm and we're not able to adapt to that warm temperature, because it becomes too cold and we're not able to adapt. Rather, it'll come because the plants and the plankton in the ocean, the plants on land and the plankton in the ocean, can't respond very quickly to the very rapid changes that are occurring. So we've already lost approximately half of the plankton from the ocean in the last few decades at 0.85 C above baseline. So you can imagine when we get to 2 or 3 or 4 degrees C above baseline, above the beginning of the Industrial Revolution, that it's quite possible, and I would say probable, that we won't have a significant number of plankton in the ocean at all. And same thing for land plants. We have these huge temperature swings that are going on right now. We get up to 125, 130 degrees Fahrenheit. That's sufficient to denature proteins in land plants and kill all the land plants. And they just can't adapt quickly enough. How soon? Well, according to Carana's analysis, we get there by 2030, to more than 4C by 2030 and more than 10C by 2040. It certainly could happen that quickly. As Albert Bartlett, the longtime professor emeritus from Colorado University, wrote and said many times, the greatest shortcoming of the human race is our inability to understand the exponential function. We're beyond linear with respect to climate change, and it's difficult for us to wrap our minds around that, to project into the future something beyond linear.
And you're suggesting that we could be, you and I, we could be, and particularly people younger than us, could be the ones who actually see the end of the human race. Let me come back to that right after this break. More of tonight's Conversations of the Great Minds with Professor Guy McPherson right after this.